Hello, we have a new problem here that says consider a harmonic wave whose phase velocity is 3 times 10 power 8, which is the speed of light here, and a frequency of 6 times 10 power 14 hertz. Okay, and we have two parts. Let's now work on the first one. What is the shortest distance along the wave between any 2 points that have a phase difference of 30 degrees? Alright, and now this says it's a harmonic wave. It would really help to picture this. So, what's a harmonic wave? What's an example? Well, a sine wave is an example of a harmonic wave, and a sine wave would look something like this, right? Where we have 0 here, we have 90 degrees here, 180 degrees here, 270, and 360 degrees. All right. We are interested in the distance between any phase difference of 30 degrees. So for example, if we have 60 degrees here and 90 degrees here, we're trying to know what is this distance, the shortest distance, right? So this just gives you an easy way to visualize this problem and to think about it. What's something else? It's an implied hint here. We are looking at a wave, right, at a certain time. So we took a snippet of the wave. Time is not really changing here. We already have the wave and we're trying to measure the distance between 2 points that have a phase difference or a phase shift of 30 degrees. So time is not really changing, okay? Now, if we look at a wave function, let's call it anything, f, or I'm going to call it psi here, and we have an amplitude of a sine kx minus omega t, right? This is a phase. So the phase, I'm going to call it phi equals kx minus omega t. Here we took a picture of the wave, right? Time is not really changing. We're only concerned about the distance that would result in a phase shift or a phase difference of 30 degrees. So delta phase, delta phi here is 30 degrees, and this should equal k delta x, the change in the distance, minus omega times delta t, and delta t here is 0 because t is not changing. So we have delta phi equals 30 degrees equals k delta x, change in x. All right. Now, we need to convert the 30 degrees into radians. So 30 degrees would equal 30 times pi over 180, and that will be pi over 6 radians. All right, so now we know, and that's delta phi. That's the change in phase or the phase difference. Okay, now what's k? K is the magnitude of the phase vector, and k equals 2 pi over lambda. All right, do we have lambda here? We don't, but we have the frequency and we have the phase velocity, that's 3 times 10 power 8. And we know that v equal lambda f, or c here. So lambda will equal c over f, will equal 3 times 10 power 8 meters per second, divided by the frequency here is 6 times 10 power 14 hertz. And that gives us a lambda of 500 nanometers. So now k equals 2 pi divided by 500 nanometers. I'm not really going to change it. I'm going to keep it like this for now. Now I'm going to go back to this equation. Delta phi, the change in the phase or the phase difference, equals k delta x. Here we are trying to calculate delta x, the shortest distance. We just found out what k is, and we know that the phase difference, the one we're after, is 30 degrees, which we just calculated as pi over 6. So now the only unknown is delta x, and we can go ahead and calculate that. So we have pi over 6 here, or here, right, equals k, which is 2 pi divided by 500 nanometer times delta x. So delta x would equal pi over 6 times 500 nanometers divided by 2 pi, which is 500 nanometer divided by 12, which is roughly 41.67 nanometers. And that's your answer. Okay, is there an easier way to look at this problem? Well, it's a different way, and I think it's easier. Let's consider this way of thinking about this problem. We are given lambda. the wavelength of 500 nanometers. Oh, we're not given that, we just calculated it, right? What is the phase difference to go across the whole wavelength? Like if we have the same sine function here and we're going through the whole wavelength, right? What is the phase difference between here and here, right? This is 0 and this is 360 and this goes through the whole wavelength. So the wave difference here, or the phase difference here, is 360. So 360 phase difference gives you the 500 nanometer wavelengths. All right. We are trying to find the distance here. We don't know. I'm going to call it x, which would result from a phase difference of 30 degrees, and that can be anywhere. This is just an example, and that's it. We don't even need to convert this into radians. We can just cross multiply, and we can find x. It's going to be 30 times 500 nanometers divided by 360, and this gives us this is delta x, or the distance, and it's going to be the same answer, 41.667 nanometers. This might be an easier way to look at it, but the two ways are equivalent and they both give you the right answer. All right, now let's look at the second part of the question. At a given point of space, this is a very important piece here, a given point of space. So x is fixed, so delta x is 0, x is not changing. All right, how much does a phase change during the time 10 power minus 6? Express your answer in terms of 2 pi. All right. So for that second part, let's look at it the same way we looked at it, this part here. So let's copy this quickly. And we just said that x is fixed. So we're not really worried about x. And we're given the frequency, right? So we can calculate the period. The period is 1 over the frequency. So t, the period of this, so the time it takes to travel from here to here for the whole, from here to here for the whole wavelength is the period, and that's going to be 1 over 6 times 10 power 14 hertz, and it's going to be 1.667 times 10 power minus 15 seconds, roughly. So that's the period. That's the time it takes to travel through the whole wavelength. And that is 2 pi, or 360 degrees, right? We can keep everything in terms of radians, or we can do degrees. So let's go back to the problem really quickly. What are we trying to calculate here? How much does the phase change? So we're trying to calculate delta phi. That's what we're after. How much does the phase change, okay? And we can calculate this in terms of radians or degrees. It really doesn't matter. And we're given t is 10 power minus 6 during that time. All right, so let's do radians. 360 is equivalent to 2 pi, right? So it takes 1.667 times 10 power minus 15 seconds to travel 2 pi. It takes this period to travel through this phase difference here. Let's call it 1, which is the whole thing, or wave of lambda. Then we have 10 power minus 6. That's what it takes to travel. What is the phase difference it takes to travel 10 power minus 6? That's what we're after here. So we can cross multiply again, and we'll have delta phi x is going to be, should have really cross multiplied with these here, right? So we're gonna have 2 pi times 10 power minus 6 seconds divided by 1.667 times 10 power minus 15, which would give us 600 times 10 power 6, all times 2 by radians. All right. Can we solve this using the same approach we used before? If this is confusing to you, then another way to solve this would be using the same notation, that change in phase equals kx. This is k times the change of x minus omega times the change of t. All right, what do we have here? And what are we trying to calculate? We're trying to calculate the change of phase. We know that we're looking at a certain point in space, so delta x is 0, it's not really changing. And we're given delta t. So if we have omega, we have our answer. what's omega? Omega is equal to 2 pi f, right? And we're given f, so 2 pi times 6 times 10 power 14 hertz. So we have delta phi, the change in phase will be, we can ignore the minus here because we're looking at delta, so it doesn't really matter. So I'm gonna say omega delta t, right? And that's going to be this. This is omega 2 pi 6 times 10 power 14 hertz times 10 power minus 6. That's delta t, right? Because here it says during the time. So the change in time is 10 to the power of minus 6 seconds. We do this calculation, and we will get the same answer we got before, 600 times 10 power 6 times 2 pi radians. And of course, you can convert this to degrees if you want. Thank you for watching, and let me know if you have any questions.